All right, all right, all right. Grade 12 students, good evening, good evening, good evening. Welcome back to one more session of your WOC. Yes, out of your 30 days, we are on day 11. It's a huge achievement. In all these 10 days, what did we learn? Let us once recollect what did we learn. So we have learned one chapter, that is solutions chapter, completely. Then we have studied haloalkenes and haloarenes chapter completely. Now we are on which chapter? Yes, we are on the electrochemistry chapter. Yes, students, you heard it right. So this electrochemistry chapter, I have already sent you one important video yesterday that is nothing but electrochemistry one-page revision. So in this series, as I said, the next coming 5 days, we are going to cover 1 mark question, 2 mark, 3 mark, 5 mark, as well as numericals. This is the heart of your electrochemistry. I'm going to take that heart and make you practice. All right? All right. So in this series, to all the new students who are joining me for the first time, good evening. How are you all doing? God bless you all. For all the old students who are there with me, hi students, don't worry, relax yourself. But important thing, study every day. Don't say, ma'am, Vani ma'am said to relax. You will relax. No, no, no. You have to study every day. Revise and re-revise and re-revise. Yes. So, as I said, I'm going to cover your complete electrochemistry, whatever electrochemistry is there from starting from today. Your electrochemistry will be covered in 100 questions. 100 questions along with answer writing skills. I'll be teaching the answer also. You'll be writing that answer writing in the exam exactly like that. So your complete electrochemistry is done in 100 questions. Let's start off the questions. Gradually we will take, don't worry, but follow all the day series students, because all questions are interrelated. Everything is interrelated. Chala, let's start the question. First question. Solutions of two electrolytes A and B are diluted. Concentrate. Forget about everything. Take out all the tensions and concentrate. A and B are diluted. The lambda M of B increases 1.5 times, and while that of A increases to 25 times. Which of these is, or these two, is a strong electrolyte? Justify the answer. Super. Nothing. The solution in the exam. First of all, write how much, what do we have? We have electrolyte A. Correct, na? Electrolyte A. How many time? How much is it? This electrolyte A, the lambda M value, the lambda M value of B increases 1.5 times. That of A, okay, it increases 25 times itself. Okay. For electrolyte B, the lambda M value increases 1.5 times only. Okay, this is a magic. They're asking me which will have more or less. They ask me what to find, which is strong. One logic here, simple logic. Come back to the logic and understand. Always remember, students, careful. In strong electrolytes, whatever you're studying, tell me, will the strong electrolytes dissociate completely? Dilution, do they dissociate completely? Yes? No. No. The strong electrolytes on dilution, what will happen? They remain same. They will not dissociate. They will remain same. Then how do they dissociate, ma'am? They will remain same. Now how, what will happen? During dilution, only thing what happens is, on or during dilution, only one thing is going to happen. During dilution, interatomic attractions decreases. This is what happens. During dilution, interatomic attractions are going to decrease, will decrease. We're going to write this in the exam like this only, put an arrow and write, will decrease. Okay. So because of this, what will happen? Because interatomic attractions are decreasing, the lambda value is very small for them. Very small for them. Now you tell me which whose value is small? Electrolyte B is value is small, right? So conclusion of the story, or moral of the story is, conclusion is B is a strong electrolyte. B is a strong electrolyte. Easy peasy. So you're going to write the answer like this. So underline this conclusion. The examiner will give you mark. Super. Super. Next question. Gradually we will go, but 100 questions, I assure you will complete your electrochemistry. Next, which when acidilated water or acidified water, that is dilute sulfuric acid solution, is electrolyzed, will the pH of the solution be affected? Okay. So first of all, pH of the solution means what, student? What is pH of the solution? pH of the solution, but pH is nothing but H plus value. Correct? pH is nothing but negative logarithm of H plus value. Okay. They're asking what will happen to the pH of the value. First of all, let us see what will happen in the reaction. Okay. At anode part. Okay. So I'm writing the anodic reaction. Now you see, what is this? Acidified water. Water, this is acidified water. So I'm going to take water. What am I adding? I'm adding acid. Acid concentration is nothing but the H plus concentration. So what am I doing? Electrolysis happening to water. When electrolysis happens to water, what will happen? It will break up into H plus ion. It will break up into oxygen also. Along with this, there's transfer of electrons. The transfer of electrons. Now, let me balance this. Taking 2 moles of water. So this will become 4H plus. When it is 4H plus, how many electrons are getting transferred? 4 electrons are getting transferred. Now you only tell me cathode what will happen. Anode though it will give the electrons. Cathode it will start taking the electrons, correct? Na? It will start taking the electrons. So this 4H plus takes up that 4 electrons, and what is it going to happen to hydrogen gas is going to happen. Is that this is oxygen gas, this is hydrogen gas. Now you only tell me, students, pH of the solution anywhere did it change? Only there is exchange of ions. So that means from anode to cathode, there is exchange of ions, but conclusion of the story or the conclusion of the question is whenever you're adding H plus ions, it is only for the transfer, but pH of the solution will not be affected. Solution will not be affected. Why it will not be affected? Because as you have seen, H plus is constant. Now see here, this and this is constant both the ways, because you write this one in the exam, because H plus concentration remains constant. Easy, easy, very easy. I have taught you the answer writing skill. Let us see the next question. How does the density of the electrolyte change when lead storage battery is discharged? Okay. So first of all, what is density? Density is equal to mass by volume. Correct? Yeah. Now they are asking density of the electrolyte. What is electrolyte in dead storage battery? Let us write the reaction. First of all, I'm going to take lead. I'm going to add PbO2. Okay. That lead plates are coated, right? PbO2. The electrolyte here is sulfuric acid. Okay. Now what will happen? Lead sulfate is formed. PbSO4 is formed. What is released out? Water is released. So I'm going to balance this now. So this is 2 and this is also 2 and this is also 2. Correct now? Now tell me density of water. What is happening? The density, first of all, electrolyte will talk. Density of the electrolyte, gradually what is happening from sulfuric acid, it is getting converted to water. Correct na? So the mass of this is your electrolyte. The electrolyte getting converted to water means what is happening? Mass is getting converted. That means automatically the density also changes. Correct? That means the conclusion of the story here is, according to the reaction, density of electrolyte, whatever, that is nothing but your sulfuric acid, it decreases. Why it decreases? As water is formed. As water is formed. Correct? Na? This is the thing. Reason simple. Sulfuric acid is consumed. Sulfuric acid is consumed as a product during discharge because that is utilized to form lead sulfate, right? So as water is formed and H2SO4 is H2SO4 is consumed. Your H2SO4 is, you're going to write this and leave. The examiner will give you full marks. Yeah. Next question. Why are or why on dilution the lambda m of acetic acid increases drastically while that of CONA decrease? This increases gradually. This increases. Okay, one second. Why on dilution the lambda m value of acetic acid increases drastically and that of H3CONA increases gradually? Okay, let us understand. First of all, I'm taking CH3COH. What is CH3COH? Students? The weak electrolyte. Okay, this is a weak electrolyte axis. When it is weak electrolyte, the number of ions, so I'm diluting this weak electrolyte. On dilution, weak electrolytes will dissociate. On dilution, what happened? Number of ions increases of acetic acid, it increases. So why? Because the degree of dissociation, whatever degree of dissociation is there, that also increases. Perfect. Okay. Now, this is your weak acid over. Let us go to next acid. CH3CONA. Now, in CHNA, what is this? A strong electrolyte. Correct? Na? I've done a video also how to identify weak electrodes and strong electrodes. In strong electrolytes, what happens? You're diluting. Correct? Number of ions remains same. By on dilution. What is the reason? For strong electrode, there is no complete dissociation because only interionic or interionic interatomic rather interatomic. I'll write atomic. Okay, atomic forces only will decrease. Correct, na? Or interionic rather. If you break up into plus or minus, I'll write interionic so that it's not confusing for you all. In the exam, you can write the same because CH3CO plus and CON, right? Interionic forces. Only interionic forces will change or decreases. Interionic forces decreases. So in CH3CON, the number of ions will remain same. Only the forces will weaken during dissociation. So that's the reason. See here, this being weak electrolyte. That's why it increases drastically. This being strong electrolyte increases gradually. So hence you can write as hence lambda m increases drastically. Here you can write hence lambda m increases drastically. That is gradually, this is drastic. So did I write it wrong? Sorry, I wrote it wrong. Once again, I'll just erase it. Some fellow is shouting outside, little distraction. Okay, this gradually. Okay, all right. This is done, students. This is drastically. This is gradually. Over. Next question. What is the relationship between Gibbs free energy of the cell reaction in galvanic cell and EMF of the cell? When will the maximum work done in the galvanic cell? Simple, students. If first of all maximum work, we will write it so that examiner will know. They asked me relationship between Gibbs free energy of the cell and the free energy of the cell reaction, the galvanic cell and EMF. These two relations I've tried. Okay. What is Gibbs free energy? Delta G is equal to minus N F E cell. This is what? No? So somebody fellow is selling something outside. It is irritating. Okay. This Gibbs free energy. Now, here, when will the maximum work? This is part A. When will the maximum work be done or obtained from a galvanic cell? When or if the concentrations of whatever you're taking, the concentrations of all the concentration of all the reacting species is unit. When this is the case, then only maximum work will be done. Maximum work will be. This is done, students. This is also done. Done. Next question. Calculate the EMF of the cell. Calculate the EMF of the cell in which the following reactions takes. Okay. This is almost a 3 marks question. Rather, if I have to take 3 marks question. So nickel. Okay. These two are the electrolytes. Okay. So the ions. This is the concentration given. What should I calculate? EMF of the cell is what I have to calculate. Simple. First of all, what did they give me? Did they give me anything? Not in the examiner, students. They will give you E naught cell value. Okay. So for this particular cell, E naught cell value is 1.05 volts. Now I'm going to apply which one? Nernst equation. Let us write first according to Nernst equation. Your Nernst equation, student. Nernst equation formula is cell is equal to E naught cell minus 0.059 by n log nickel Ni plus 2 divided by Ag plus. Okay, this is done. Ag plus, and let us apply the values. Let us apply the values. When I apply the values, it is 1.05 minus 0.059 divided by 2 log. How much is the concentration of nickel given? Nickel concentration given is 0.160. So this 0.160. Okay. Any charges there, students? Nickel plus 2 only, na? Nah. And how much is the silver? It is 0.002. This 0. When I solve this whole thing, I have done one video, that is how to calculate log without a log table. Log without a log table. Without log table. I did one video. You can watch that video. Okay. So yeah, the answer, when I calculated, I got an answer of 0.9143 volts. So you can calculate that. You can check this video. I did that video and the answer is in front. Right? Chalo. Next, gradually, students, I'm going to go to one more question. The molar conductivity of 0.025 mole lead inverse methanoic acid is 46.1 Siemens centimeter square mole inverse. Okay. Calculate its degree of dissociation and dissociation constant given the value of HCO minus. Simple. Don't get confused. Easy question. I'll tell you. First of all, note the given values. Solution. So what did they give me? Methanoic acid. Okay. Lambda C. Okay. First of all, the molar conductivity. Molar conductivity value for methanoic acid given is 46.1 Siemens centimeter square mole inverse. Then what do they give me? They've given the concentration. Did they give me? Yes. The conductivity. They molar conductivity value is 0.025 mole inverse is what they gave me. Okay. Then did they give me anything else? Nothing. They asked me to calculate. First of all, methanoic acid. Calculate using Kohlrausch law. It depends upon the independent ions, right? Individual H plus ion plus not HCOO minus. How much is this H plus ion value? H plus ion value given to me is, did they give me anything? Okay. H plus ion value, they didn't give me how. In the exam, in the table, they will be giving that value. So you can directly apply. So this, it is 349.6. Okay, 349.6 plus for HCO minus they have given it as 54.6. So when you add together, it comes to it is equal to lambda naught HCO minus value comes to almost 404, which I calculated already. 404 Siemens centimeter square mole inverse. This is done. Why did I do this? Because they asked me to calculate degree of dissociation constant. Let us write the formula. First of all, degree of dissociation. What is the formula, students? Degree of dissociation. Okay. What is the formula? Lambda C by lambda naught. I got this value now. What is dissociation constant? Dissociation constant formula is AA. What is this? Alpha square by 1 minus alpha. What is lambda C value? Did they give me lambda C? Yes, they've given me 46.1. This 46.1. This lambda naught value I got here na, this 404.2. When you calculate, I think I got an answer of 0.114. Okay, this is what. Let us apply. Concentration, how much did they give me? So conductivity 0.0025. Apply that 0.02. Alpha square value. Did they give me alpha square alpha? Okay. 4. All right. 6. Okay. Alpha square value, degree of dissociation 0.114. Okay. Square divided by 1 minus 0. When I take this, when I calculate, I get an answer of almost 0.00036667, which finally I have round it off to 3.67 into 10 raised to the. This is what I got. Question, students, easy. Next question. Let us see. Further, we are going to do. Calculate lambda m for calcium chloride and magnesium sulfate and from the data given. Okay, from the data given. All right. So the data is given for me. Calcium chloride. First, let us calculate for lambda calcium chloride. Calcium chloride is made up of what ion, student? Is made up of lambda naught calcium plus 2 plus chlorides are 2 Cl minus 1 2 lambda C. How much is lambda naught calcium? Is it is 119.0 plus 2 into 76 point. How much is it's coming to? When I add, put together, multiply, I'll be getting around 271.6 Siemens centimeter square mole. Okay. Now we'll do for magnesium sulfate. Okay. For magnesium, it's made of lambda naught Mg plus 2 plus lambda naught SO4 minus. And how much is given for magnesium and sulfate? Okay, both are given here. I'm going to use that. How much is for magnesium? 106. How much is for sulfate? 160. Am I right or wrong? Am I right or wrong? Yes. Okay, that. When you add this together, you get two. I think, yeah, 266 Siemens centimeter square mole inverse is what I got. And they asked me that already. Calculate lambda m for calcium chloride, magnesium sulfate. So I used which law? Used Roche law, called Roche law of independent migration of ions. Done. Done. Let's see the next question quickly. Conductivity of 0.001028 milliliter inverse acetic acid is so much. Calculate the dissociation constant. Lambda naught for acetic acid is so much. So what did they ask me? They asked me to calculate dissociation constant. What is the formula? First learn the formula. I've sent formulas yesterday. Yeah. So first solution. I have to calculate the dissociation constant first. Then dissociation constant, I should write this. Dissociation constant. Dissociation constant is Ka. Correct. Ka, what is the formula? Ka is equal to alpha square by 1 minus alpha. Correct. From where will I get Ka? Where will I get Ka? K from the earlier formula, and I should also get alpha value. Go back. We very well know lambda m is equal to A into 1000 by C. First we'll calculate K value given to me. K value given to me is 4 point into 10 raised to minus. This is 1000. Okay. 1000 divided by how much is C value given to me? P90. P90.5 S centimeter square. Done, students. I calculate from here. I got answer when I worked on this. I got an answer of 48.5 centimeter square mole. You also divide, calculate, and do it. Yeah. Then from there, I'm going to calculate alpha because I need alpha na. Lambda n by lambda naught m. What is lambda m? I got 48.15. 48 point. What is not? 90.0 is equal to 0.12. I got. Go back to your dissociation constant sum now. Take the dissociation. A is equal to alpha squared by 1 minus alpha. How much is C value you got? Now, earlier you have no 0.0010. Yeah. Here the C value, whatever is there, it will be given like this in the sum, or it will be given as a separate thing below the table. The conductivity already they give. I'm going to use that. 0.001028 into alpha is how much? 0.123 here divided by 1 minus 0.12. Get the K value. I'll be getting an answer. I got worked up 0.78 into 10 raised to 4. So this is your dissociation constant value. Ka. This is what you got. Question. The conductivity of 0.020 solution of KCl at 298 Kelvin is. So, So calculate its molar conductivity. Careful students, understand the question. First of all, 2.20 molar solution contains so much. Correct? That is right. So what is 0.2 molar solution means? Nothing but zero point 0.2 moles of KCl, right? Of KCl. Where is it present? Present in present in 1 liter of 1 liter of solution. What 1 liter? 1 liter means it is 1,000 centimeter cube of solution. 1,000 centimeter cube of solution. Do you accept? Okay. Now, so I can conclude 1 mole KCl is present in mole KCl is present in 1,000 by zero point 0.2 centimeter cube of solution. Write this. Yes. So now easy, easy. Let us see. Now what can we do? K value, how much did they give me? K value, they have given me a 0.02. Write that. K is 0.0248 Siemen centimeter inverse. So it this is what conductance of 1 centimeter cube solution. So write this as 0.485 Okay. And okay. Now what is conductivity? Now what is this conductance? Conductance of 1,000 divided by zero point 0.2 centimeter cube is equal to 0.028 into 1,000 divided by is equal to what? 124 Siemens centimeter square mole. So, molar conductivity, what is the molar conductivity value? The molar conductivity value is nothing but the students. Let's see the next question. Let us wait for. Let us wait. Let us just go through the next question. Write the question and find EMF of the following cell at 298 Kelvin. So magnesium solid, magnesium. This one is there. They're asking me to find out the Nernst equation. All right, students. So can you just do the sum and tell me how much is the answer in the comment section? Yes. So what I'll do is I'll be solving this question next video. So I'll meet you in the next video. So for today, practice these. Tomorrow, these questions will be coming. We have so many questions, more many questions, students. So many are there. I'll be doing all the sums in my next week. All right. Signing off. Thank you so much. Meet you all tomorrow. Meet you all. Bye. Take care. Any doubt? Ask me in comments. See you tomorrow. Take care.